Okay, today I'm going to talk to you about half-life. Now, the half-life of a radioactive isotope is the time taken for half of the undecayed nuclei to decay. So first of all, what we need to know is, what does decay mean? So decay just means to break down. Radioactive nuclei, shown here by the red nuclei right here, these show that these are unstable. They could break down at any time, and this breaking down is called decaying. Now, what the half-life is the time taken for half of these nuclei to decay. So what I'm doing is I'm just randomly picking 4 of those nuclei to have decayed between this time and this time. So these 4 have now decayed. As they decay, they emit, means give out, radiation. So the same amount of time will be in between here as it will be here. So we can see that now there's 4 remaining unstable radioactive nuclei. So between these 2 places, another 2 are going to decay, and more radiation is emitted by the ones that have just decayed. So we can see this time in between half of the nuclei decaying is called the half-life. And as we can see, each time we have decay, less radiation is emitted at each point. So we're going to look at how to do a half-life calculation. So a typical question might be, we start off with 1000 BQ. This just means becquerels. This is just a measure of radioactivity. And after 6 hours, a 6-hour period, we take another measurement and we now have 125 BQ, becquerels. So the question will be, what is the half-life? How long does it take for half of these radioactive nuclei to decay? So what we need to do is we start off with 1000. This is the amount of radioactivity we detected at the beginning. So in order for half of these radioactive nuclei to decay, our next reading would be 500. This shows that half of those radioactive nuclei have decayed. However, this isn't at our desired number quite yet. So all we do is we imagine this half of these nuclei decaying. So this time we have a reading of 250. Again, all that we've done is we've divided by 2 to get half the number of radioactive nuclei. Again, we're not a desired value, so we're going to do it again. Again, half of these radioactive nuclei decaying has given us now our correct reading. So we can see it's taken 6 hours to get from 1000 to 125, and we've gone through 3 different half-lives. So in order to calculate the half-life, what we do is we take 6 hours, which is the whole time it's taken to get from here to here, and we divide it by 3, because we have gone through 3 separate half-lives. So the half-life of this particular radioactive material is 2 hours. We can also find the half-life from a graph. So up the y-axis, we might have a reading of radioactivity in, radioactivity again in BQ. Along the x-axis, we might have time in hours. Now, radioactivity graphs look like this. Please notice that it never reaches 0, because each time the nuclei are just halving. So it never ever reaches 0. So to find, using a graph, to find the half-life, what we need to do is this. So let's say at 500, at time 0, we have this much radiation, 500 BQ. So what we do is we think, well, the half of 500 is 250. So what we have to do is we have to extrapolate the graph, and we see how long it's taken for half of those radioactive nuclei to decay. So the answer is 1 hour for this particular substance. Now, different isotopes can have very different half-lives. It could be a matter of seconds, or it could be millions of years. It depends on how unstable the radioactive nuclei are. So just to recap, half-life is the time taken for half of the radioactive nuclei to decay. The amount of radiation emitted decreases over time because there's fewer nuclides left to decay. And here is how to calculate the half-life using a calculation. And here's how to calculate the half-life using a graph. Thank you.